To understand the chain rule, we first look at composite functions, where one function is nested inside another. Here, g of x is the inner function, and its output becomes the input for the outer function f. The chain rule states that the derivative of a composite function is the derivative of the outer function with respect to the inner, multiplied by the derivative of the inner function itself. First, we differentiate the outer layer using the power rule. The derivative of u to the fourth becomes for u cubed, keeping the inner expression intact for now. Next, we find the derivative of the inner function. The derivative of 3x squared plus 5 is simply 6x, as the constant 5 disappears during differentiation. Now we multiply the two results together. We take our outer derivative, 4 times the quantity 3x squared plus 5 cubed, and multiply it by our inner derivative, 6x. Graphically, the chain rule shows how the rate of change of the outer function is scaled by the rate of change of the inner function at any given point on the curve. This works for all functions. For sine of x squared, the outer derivative is cosine of x squared, which we then multiply by the inner derivative, 2x, to get our final answer. Leibniz notation makes this easy to remember. It looks like the do terms cancel out, leaving you with dy over dx, though remember these represent limits of changes, not actual fractions. You have now successfully applied the chain rule to composite functions. Practice identifying the inner and outer layers to solve even more complex problems. Generated by Vision Solve AI.